So, a little bit about myself. My name is Ariel Alonso. I'm currently playing the role of a system architect over at IPC. As Rick mentioned, IPC is primarily it's a supply chain company for the Subway restaurants. It started out that way. The company has grown to include a lot of services and products that benefit the franchisees, the Subway franchisees. Anything that can make a franchisee profitable, whether it be lowering food costs, or equipment costs, or insurance, and all manner of services. But recently it's turned into also IT, a lot of IT projects that IPC has taken on. And one of the major projects that is going on right now is the point of sale. It's actually all of the point of sale software that will be installed on all the machines in North America. And the other main project is the gift and loyalty and credit card payment processing company, which I'll share a little bit more about towards the end of the presentation. I've been a software engineer for about 15 years. I have interest in Agile and XP, extreme programming. I have a passion for test-driven development, automation of every kind. Recently I've been more interested in business intelligence and distributed systems, distributed architecture, and big data in general. So that's just a little bit about me, about the kind of things I'm interested in. So as far as the agenda for this conversation, we want to talk about defining what continuous delivery is. I'm going to give you what I think it is, what it means to me. Then we'll talk about some steps that you can use to implement continuous delivery, because I think once you understand what it is, it's very important to actually have steps and things that you can try to implement on your own. And then I'll share a little bit about how continuous delivery actually came to be at IPC, how it's benefited us, and how we actually implemented it. And then we can take questions. So I'd hope that we can have more questions at the end. So I'd rather be more interactive towards the end. So hopefully we can leave the questions until we're done. So what is continuous delivery? Well, I think I like to describe this by asking a question that we can all just consider together. And I'll start by posing this question. How long would it take your organization to deploy a change into production that involves just a single line of code? So put aside why we would actually just deploy a single line of code. We'll get to that. But how long would it take your organization? What's the level of effort? How many people would have to be involved? How many processes would you have to implement, etc.? So think of all these things. And how long would it take to get that one line of code into production? But a more intriguing question is, do you do this on a repeatable, reliable basis? So this question is actually more important than the first one. The reason for that is because if this was a competition and we said, okay, what organizations can get something out into production, right? We can all, we can set up a task force, we can set up a SWAT team, and right, everybody, employs heroics, and everybody gets on deck, and you could push stuff out, and sure, we can do that. But the important part is this repeatable? Is it reliable? Is that really sustainable to rely on the heroics of people, to ask them to converge every single time we needed to do something like this? And the answer is more than likely no. So because this process in most organizations, and I've been a part of a lot of organizations, I've been in a lot of projects where it is a painful thing to do, we tend to avoid deploying because it's painful. So we tend to push it out. So the interesting question is here, why would we ever deploy a single line of code into production? We would never do that. In fact, the amount of difficulty or the stress or the pain that you feel when deploying is probably what drives how many features you actually wait to put into your release before you go out, right? So if it's very easy for you to do so, then one line of code is no big deal. But if it's a very painful process, you're probably going to wait and delay until you've got enough features before it's actually makes sense or worth the pain of actually deploying into production. And that's actually not what we want. That's actually worse for a lot of reasons, right? The business obviously wants features faster, but that's actually riskier to do. So when we start thinking about all this and we start thinking about all the processes that it takes to deploy into production, a lot of different organizations have different processes. We have different things that we've got to account for. We've got maintenance issues. We've got processes. We've got waterfall things still lurking. We've got staging, change control, all sorts of things. And all of this leads to us wanting to do it less. And that's actually not what we want. So we've all heard about Agile, we've heard about Scrum. A lot of organizations are moving towards that, and I have a particular issue with some of the way the Scrum is prescribed, because it's supposed to answer these problems. It's supposed to. So I talk to a lot of organizations that say, well, we do Agile, we do Scrum, and then I ask, well, okay, so how often are you doing these kind of deployments? And it's like every 2 months. I said, okay, well, that's not Scrum, that's not Agile. So what is the breakdown? Why is it that Agile doesn't get us all the way to the end? Well, it's because of what Scrum actually does, and from my perspective. Scrum is very good at helping us understand and decompose functionality from big monolithic requirements and huge documents down into bite-sized pieces of stuff that we can all understand, we can all wrap our heads around, we can all we can all understand that what the definition of done is. So all that stuff is built into Scrum. We're all pretty comfortable with that. I think a lot of companies do that. What does that give us? It gives us more frequent feedback. So product owners are more involved. The users are likely more involved in the iterative process. So we get feedback more frequently. These are all things Scrum actually does do that I do agree with. But the key indication is what Scrum actually delivers. What Scrum delivers is a shippable increment, and this is where the distinction is. This is where where the cycle ends on an iteration in Scrum. Development happens. There's testing. There's review with the product owner, and then you have a shippable increment. But shippable doesn't do me any good because it's not in production. It's just shippable. So what ends up happening is that Scrum allows you, and all these tools and ceremonies, which are great in and of themselves, but if they're not part of a bigger strategy, then all you have is a log jam, a backlog of shippable increments if your process to deploy is actually painful. So we talk about shippable increments, we talk about smaller pieces of functionality, we talk about built-in tests and all this great stuff that Agile and Scrum do, but what about deployments? Nothing about Scrum talks about getting this into production. Very few definitions of Scrum actually include in production. It's just basically when it's shippable. Then the team can move on to the next feature set, and it's now waterfalled into the production team or the operations team to deploy this, right? So it's not really Agile anymore if there's one piece of the puzzle that's very waterfall. So why is that important? Well, because value is only realized in production. It doesn't matter how great this shiny new feature you have is in a nice little bow and package in a shippable increment if it's sitting over here in development land. If it's not in production, it doesn't matter. There's no value. Deployments, most of the time, are manual. Most organizations still have, regardless of how much we automate the process of building software and building code and building tests and automating tests, if we're doing that, but still somewhere along the line there's a breakdown in the automation, and deployments are still manual. They're very, very, very manual. And what's the problem with manual is that they're painful. Checklists, and you've got change control, and you've got detailed instructions, and you've got all these things that you have to follow and make sure that you get right, or else something blows up. And that makes it very error prone. And in making it error prone and painful, you're going to want to do it less. So again, this is all back to I don't want to do this as often, I don't want to do this a lot, I want to do this as infrequently as possible, and that's very bad. Another thing that happens is you'll have environments where they're very different. So a lot of times the way we get a development build of a product, a brand new feature, and we get it in front of our product owners to view, the way we get that software, that shiny new feature, into a demo environment is oftentimes, most times, very different than the way it actually goes into production. And that's a key distinction, because now you've introduced change, you've introduced an unpredictability to the process. Because I cannot, as a developer, I cannot guarantee that this feature, when we go live, when production deployment actually happens, I can't guarantee end to end that everything's going to be fine, because I've tested features, but I haven't actually tested the deployment necessarily. It's still manual, it's potentially different, the configurations are different. So this, again, leads to something that's very, very, you want to avoid doing this. So you get more infrequent deployments, which actually increases your risk. If you wait long and you get your feature set to be very, very large, and you deploy to production, now you're looking at 100 things that you're monitoring, you're constantly trying to be on top of, you're trying to make sure that none of these things go wrong. It's more things to be looking at the same time. And that actually increases our risk. So it's actually backwards what we want, and this is where it's a little bit different. The idea is if something hurts, we want to do it more often, not avoid it. I'll talk a little bit more about that a little bit. So, why do we want frequent deployments? Well, deploying frequently has a few advantages. First of all, we want feedback from our actual users. Feedback from our product owners is good. Feedback from our QA people is good, and feedback from the business is good. But the users is what we want our feedback from, right? If you're thinking about a minimum viable product, if you're beta testing something, if you're trying to put something out for early adopters, as an example, you want to get that out as fast as possible. You've got your development team rushing and doing iterations to get the feature built. You want to get that out in front of your users as fast as possible to get your feedback. You want to reduce the risk of deployment. The more you deploy, the better you become at it, the more you automate it, and the smaller the pieces of change that you're introducing into your ecosystem, into your production environments. That allows you to be laser focused on exactly what you're deploying and what you need to be aware of when you deploy. Should you come into problems, you can roll back. There's a potential, a small little change that that went into this release. This is really the only way we can measure project progress. It's actually when you get to production, because you can have iterations and you can scope out your project to be multiple iterations. But if you're iterating and developing, but you're actually not deploying these iterations into production, well, your progress isn't really your progress. You have made progress. Progress is when you can actually get stuff and features in front of your users. So frequent deployments obviously give us business value quicker. Faster we can get this feature into production, the more value we get. So this is the goal. We want more frequent changes with fewer lines of code because they reduce the risk and help identify problems easier and sooner. So how do we do that? So I borrowed these slides from John Allspaw, who is he's a real big DevOps guy, and he had a really good presentation called Ops Metametrics. And he basically describes this is a traditional waterfall project where over the course of time there's huge steps, huge change sets being introduced into production. And this is very, very risky. What we want to get to is over the same period of time, we just want to do baby steps. We want to be able to release the same functionality in smaller increments so that we can be very hyper-focused on exactly what's going into production. And at the same time, what happens here is you're getting better at this process. The better you get at deploying, the easier it is to do it, and the less risk you actually have. So, what is continuous delivery? What do we mean when we say continuous delivery? Well, it's really just a set of guidelines. It's a set of principles and practices that you can follow. And the key distinction here is it's a set of software development practices and principles focused on building, testing, and deploying software faster and more frequently. So this is usually where Agile sort of leaves off. It's not just the building and testing, it's the deployment as well. Two major goals in continuous delivery. We want to improve quality and at the same time reduce cycle time. It's kind of hard, right? Those are two things that are usually harder. If you want to improve the quality, we think that we have to slow down and actually take our time and do bigger things, make sure we only do one big deployment, when in actuality, the metrics and everything proves that you actually improve your quality over time by being able to not only build your code faster, but actually vet out your deployment process and make that just as strong and as iterative as your actual development. And again, the reason is because business value is actually only realized in production. So this is often referred to as the last mile of Agile. Scrum takes us through shippable increments, but we need something else that gets us over that hump. So just to recap, Scrum gives us feedback on the quality of our ability to decompose requirements and build quality code. So Scrum does give us feedback. The distinction with continuous delivery is that it also gives us feedback, but of a different nature. It gives us feedback on the quality of our process to deliver software, which is just as important as our ability to build software. It's our ability to deploy. So I like to think of it in terms of Scrum is at the center, right? And Scrum is just a type of Agile methodology. But if you follow that through, continuous delivery is just something that wraps Scrum. It's a logical extension of Scrum. It's applying an iterative approach, which is all Agile is. It's smaller iterations, more frequent iterations, and extending that beyond just the development lifecycle and including and encompassing the actual deployment. aspect. So this is what we just want to get to, right? We just want to be able to ship. We just want to be able to write code, go fast, and ship it, and just keep going. So how do we implement continuous delivery? This all sounds great. We know how to do Agile, right? There's a lot of books and stuff like that. How do we do continuous delivery? What does it look like? So there's a set of principles, as I mentioned before. These are principles that guide, but also determine whether or not you're actually in a continuous delivery model. The process that you use to deploy your software must be repeatable and reliable. It can't be manual. It can't depend on checklists. It can't depend on anything like that could introduce variance or make it very difficult to sustain. So your process has to be repeatable and reliable. You need to automate everything. The moment something is manual, it's not automated anymore. There's a step in the between. Now you've got dependencies. Now you've got error. If it's manual, you can introduce error. We mentioned this before. If something is difficult or painful, do it more often. Why is that? Well, so if you were given a task and you said, for 8 hours a day, your task is to do these 17 things, you're probably going to find a way to automate them because you don't want to do that 17 times. So the thinking here is that you want to simplify things, you want to automate things, and the more you do it, the more you force yourself to do things that are painful, the more you're going to be forced to find a way to make it better and make it faster. Keep everything in source control. And that means everything. It's not just your code. Hopefully we're all using source control to keep our code, but we want to keep configurations. I'll talk a little bit about that later about what that means. We want to keep configurations, and we want to keep environment infrastructure in source control. We can version the way our environments look, which helps us keep our environments the same, both in development, across through all the platforms, and into production. The definition of done has to change a little bit from traditional Agile. The definition of done in Scrum is when the sprint's over and the product owner says, yeah, I've got a feature and I agree, it's the test's passed, it's good. The definition of done has to be in production. Everything you do has to build quality into the product. So we cannot rely on anything external to validate whether the product or the process to get our software into production is good. It should all be built in. And this is a very important one. Everyone has responsibility for the release process. This isn't just a developer developing code and then ops releasing into production. The developer is just as responsible for getting this piece of code into production as the production or operations team. And then get better all the time. Right? There's different degrees of all of this, and you're always looking for ways to improve and automate and improve your process. Steve Jobs had a pretty good take on this. So I'll describe the traditional pattern of continuous delivery, and what it actually looks like. So everything starts in the developer, on developers, on development machines where code is being generated and tests are being written. And you have a set of source control. So obviously, in order to automate this, you need good tools, and we'll go over some of the tools that are part of this whole ecosystem. But traditionally, you have source control, a centralized source control where all code gets merged and all your development efforts are convened. And you have automatic build servers that will build your products, run your tests, make sure everything is actually automatically being tested against changes. That's a little broken image there, but so there's your artifact is being produced by your build environment, by your build server. So every single time you check in code, you've got a new package, a new build, a new version of your product being automatically built. It's automatically tested with its unit tests, and now you've got a shippable increment. This now gets fed into an integration environment. So this is an environment that is a completely controlled environment. There's no user interaction here. The idea for this environment is this is where your products are put in to interact with each other. So say you have product A and you build it, you run your unit tests, and you have product B and you build its unit tests. You put this into your integration environment, and now you're testing how they function with each other. So this is a sandbox. This should be a representation of your ecosystem, all the moving parts together. Your single artifact is produced and advanced through the environments. So this is a very important principle. You don't deploy a different build or tag something differently into your integration environment. It's the exact same build that you put that came from your build servers is being moved into your integration environment. From there it moves into Traditionally, it's called a UAT environment. I prefer to call it a demo environment because there shouldn't be any testing here. This is really just where you're actually demoing this product now to your product owners or any users that you might have access to. The idea here is that every single time code, so this is happening automatically. You generate code, you make a single line of code change, you commit, that automatically goes into your build servers. The build server automatically builds your new artifact, puts it into your integration environment, runs all the automated tests. If it passes, it moves now the artifact into your demo environment, and now your demo environment is up to date. Your users just can constantly be checking on the progress of your build and of your feature set. But here's the key now. So what I have listed here in red is typically your production team. These are environments that your development team does not have access to, right? These are delineation of responsibilities here. The same exact artifact with the exact same process used to deploy to integration and to demo is the exact same process that's used to move that artifact into staging. The only difference is who's doing it, right? So we still want to maintain a separation between access, as far as developers having access to production and vice versa. But the tools, the mechanism by which developers use to move these artifacts into these development environments should be the exact same process that's used to move it into staging and then ultimately into production. The exact same process. The only difference is it's who has access to what environment. Now you actually have a way to prove from beginning to end that the code you've tested at a unit level, you've tested at an integration level with other, make sure it plays nice with other products. It's been actually accepted by the product owner in your demo environment. The process that actually got your products through that is actually predictable. Your process is predictable, which means that minimizes the risk of your deployments because you've practiced it 4 or 5 times already. There's nothing new here. There's nothing different in deploying to production. So what are some of the practices that we can employ to have a continuous delivery model? We build binaries only once. By binary, I mean if your product if it's a web application, you build that once you have your unit tests and everything converged and merged and checked in and everything's good. That binary now progresses through all the environments. So if it doesn't pass one of the gates, meaning your integration environment, well then that build is not ready to go. You build a new binary. You go backwards and you fix and you build again. You don't patch products or binaries along the way. We want to use precisely the same mechanism. That's very important. We want the exact same thing to guarantee predictability and reduce risk. We don't want to make any processes that have a slight variation in production than they do in development. We want to smoke test our application. So this doesn't mean run a full test in production. This means smoke test. It's a very targeted test. It could be, if it's a website, it's something as easy as logging in, right? We want to prove, because this is the definition of done. It means that the feature went all the way from development all the way into production, and everything is exactly what we expect it to be. And if anything fails, we stop the line. So stopping the line comes from the lean manufacturing, where Agile kind of started. And it means that if your assembly line, you're progressing your product through the assembly line, if something happens along the way, it finds an error, something doesn't play nice in the integration environment, you might find that another product is not working the way you expect, you stop the line right there. You don't try to fix it there, you don't try to, you try to figure out what happened there, but the fix is actually the problem is either in your product or in your process. You need to stop it and fix the process, or fix the product and start over. It's very important to keep the line working exactly as you expect. So another way to look at Agile, these are slightly different terms, but essentially it's the same concept, is we have this idea of prioritizing work. First thing we do is prioritize work. Iteration usually starts with taking what the business wants, decomposing it, and then figuring out what we're going to work on this week or whatever your sprint cycle is. Then we build. Once we build, we deploy, and then once we deploy, we verify. Right? This is a continuous delivery model. And then we learn. Once it's in production, we learn. This doesn't mean we get feedback and we figure out if it broke or not. We're actually learning. We're taking value from the feature we introduce. We maybe introduce a survey. The survey's in production. Now we can actually collect data and learn from it. What's important about this diagram is that these arrows in between prioritize and build and deploy and verify, they have they have the potential to create backlogs. So if your process is prioritizing way too much work, or your backlog is getting way too big, now you've got a queue that's too big, and your pipeline of build is not, you don't have enough resources to build all this. So you can develop a backlog that's just not feasible to get through. At the same time, if you're building a lot, right, so you're doing a lot of Scrum and you're doing iterations, let's say you're doing weekly sprints, and you're building shippable artifacts, but your production team can't get these builds into production or get them out, now you have a backlog of artifacts that are just not ready to go. So you've got this backlog right at your deploy stage. So it's very important to manage all these queues along the way. You want to prioritize just the right amount of work that you can actually commit to, you can actually build, deploy, verify, and keep going. So this is just, I saw this, Nathan Harris, who's one of the analysts at Gartner, described this, and I thought it was interesting to view in this way. So there's some key building blocks to making a continuous delivery model. Source control is very important, and I'll go over some of these in a little bit more detail. Source control is very important. Test-driven design. I like to call it test-driven design as opposed to test-driven development. Behavior-driven design is also very, very instrumental. Automated testing. Continuous integration. And infrastructure as code. So let's go first into source control. So source control, I think most people know what source control is, but it's an essential. It's very essential for development teams to work, especially when you have distributed teams. If you have multiple features, you might branch. You might have you can work very effectively and converge different streams of features using source control. So it's very effective. One of the ability to move forward and backwards through revisions is obviously you can roll back. If you need to fix something that's in production from a previous version, you can always go backwards in time, check out your code from a snapshot or from a tag, and make changes to it and release the change. But one of the interesting things that I've seen used a lot is, as it relates to source control, is you can attach. I'll go back to this one. You can attach production line stopping into your commit hooks. So when we said stop the line, a lot of organizations will use a hook that if your unit test fails, it automatically stops accepting any future commits. So it forces you to actually fix the problem before you can check in on any other code, right? You can check in code to fix it, but you can't check in any other code. So that's sort of like, that's an example of using the tool to actually enforce that stopping the line mentality. And the one before that is just source control allows you to attach historical data to code, like comments. You can attach comments to your changes, which allows you to track over time things that have changed in your source code. Continuous integration. Continuous integration is a concept where you have a central place where all code changes that are coming from all your various development teams are merged in a single place to make sure that there are no conflicts between what developers are working in separate copies of the application. And it merges everything into a single main line. And this single main line is where your actual artifacts are built from. They're not built from branches, they're not built from rogue builds or development builds. Your binaries all come from your primary main line and now progress through your environments. So your continuous integration servers, your tools will automatically build the entire application. There are no manual steps, there are no release managers, there are no people with their desktops checking out code and building artifacts. It happens automatically. The continuous integration environment is where your automated unit and functional tests occur as well. So every time you check in code, it's checked and compiled to make sure there are no conflicts between your code commits. But it's also making sure that tests that have existed in your code base have not been affected by new code coming in. So it's a regression test that runs, and a unit test that runs automatically on every single commit. The benefit of continuous integration, one of the biggest benefits, is that it exposes integration issues early, and we want to get, if there's problem with something I wrote that conflicts with something someone else wrote, I want to get to that. I want to know about that as soon as I possibly can. I don't want to wait days before I know that something I contributed is not compatible. And the most important part of continuous integration as it relates to continuous delivery is that CI is the responsibility of everybody. There isn't a build master or a bamboo master or whatever your tool is. It's the responsibility of the entire team. If something is not green, if something is broken because somebody checked it in, then everyone's responsible. Your testers are responsible, your developers are responsible. Everyone's responsible for making this process work and be reliable. So test-driven design. Test-driven design is a concept of developing software that says you always want to start implementing code in a way that you're testing first what you're trying to prove or what you're trying to build. You build the test case that allows you to prove when you're done, essentially is what it is. You start always in a red state. We say red, green, refactor. We start in a red state. Red means my feature doesn't work. Of course my feature doesn't work because I haven't written it yet. It's the first reason why it doesn't work. Then you start to implement your feature and your test passes. And then this is iterative. You make a change, you make sure your test can fail. The reason why we start with a red state is because it's very important that our tests can fail. If our tests cannot fail, then they're not reliable. So we have to first prove that our tests are failing and failing for the right reasons, and that allows us to go back and make our implementation to pass. Test-driven development is a way of building in permanent regression into your application. So test cases only expand as your feature set expands, your unit tests increase in your application, and they stay for the life of that feature. So if your features over 2, 3, 4, 5, 6 years, your application grows in scope, it grows in feature set, so does your test cases, and they stay as part of it to make sure that as you introduce new features, you're not breaking old ones. I find that code that is written using a test-driven design doesn't need documentation. It's actually self-documenting. Your test cases actually describe what your application is supposed to do. So it's actually a lot easier to go into an application if it's been written with a lot of unit tests and a test-driven design, and you could just read through your test cases and understand at a very high level very quickly what the application is actually supposed to do. So it's actually one of the best forms of documentation. It leads to more maintainable code. When you write your code in a way that has to be tested, you end up writing it more maintainable because it's very difficult to write. It's very difficult to test very big methods. It's very difficult to test convoluted if statements and nested ifs and all sorts of complexities that we normally introduce into code. And at the end of the day, you get better code. So behavior-driven development is a little bit of a difference. Unit testing is something that test-driven development usually applies mostly to unit tests. Behavior-driven development, it starts with a conversation. It actually brings in the product owners into the conversation when talking about a feature. And the goal of behavior-driven development is you want to get to a shared understanding of what the features are. So this isn't just a developer saying, well, I want this method to do this, so I'm going to write a test that makes sure my method does this. That's at the unit level. Behavior-driven is more like you want everyone involved in the delivery team, right? And that includes your developers, that includes your testers, that includes your product owners. You want everybody agreeing on how this feature should work. Say it's a login page. When I log in, I should be redirected to this page, and I should get a message. Let's just say that's the example. So now we're speaking of it in terms that everyone understands. It's not necessarily code speak. Essentially, what you're writing are stories inside your code that you can express them as stories. You can describe your behaviors and your features actually in code, and this is one example of an actual framework language. This is Cucumber. This allows somebody to write a test case, and this is actually executable. This is not just pseudo English. It actually is an executable test. So, as an example here, you can describe a feature that just sort of illustrates your story. So you see there's the typical story format. In order to make the customer whole as the product owner, I want to make sure we know how to do math. So the scenario is a customer refund. Given Fred has bought a microwave and the microwave costs $100 US, when we refund the microwave, then Fred should be refunded $100 US. So this is something that's very easy to understand. Everybody can agree, yes, if this test passes, we're done. The feature is actually done. And there are a lot of good tools and frameworks that allow you to express tests and stories in this fashion, and they get built into your application. They're not separate tools. They're not separate documentation that goes outside. This is actually built into your code. Automated testing. There's a lot of different types of testing you can do, and most of them can be automated. Unit testing, we talked about, is definitely automatable. There's a lot of frameworks that are very, very good in whatever language you use, whatever technology stack you use. There's a lot of unit testing frameworks that help you automate and run your unit tests. Then there's functional testing. Functional testing is a little different than unit testing. Unit testing is very, very low level. It's very, very focused and specific on granular functionality within your application. Functional testing is more about it describes more of how stories work. It's more about an interaction of behavior. When I do this and certain other things, how do these parts all connect? And this type of testing can also be automated. There's performance, load, and stress testing, and I won't get into the differences, but you can automate things that test that your expected performance in your application isn't getting better or worse with a change. So oftentimes we automate functional tests. I want to make sure that when I check in this code that all my features work the same way. But what if something I checked in makes my feature work the same way but it's slower? Or if I'm trying to fix a memory problem, how do I know I fixed it? If I don't have a baseline, or I don't have a way to automatically prove that as I'm making changes, I can prove that it's getting better. Security testing is also one that I don't see very often automated. Right? Did we make our application more vulnerable to attack? Did we introduce any holes in the application? Disaster recovery. If your system is a distributed system, this applies even more. But every application can fail. How do we have an automated way of testing the resiliency of our application to recover from a disaster? Those are all things that can be automated. So infrastructure as code is the concept that even your deployments can be scripted, even your environments, even your servers. And in a world now where we have virtual servers, it's very easy for us to be able to describe our entire infrastructure with code. What this lets us do is, if we have if our application depends on a particular environment, let's say it's an operating system change, and our new feature that we're implementing has a dependency on this operating system change, we can package any changes to our operating system as code. We can actually use tools that allow us to express our entire infrastructure using code. The fact that it's code means we can automate it, we can test it, just like we test actual features. So a lot of tools allow us to automate the process of bringing the system into a desired working state. This solves the problem of having your development environment be different from your production environment. So it should be that your production environment is just another environment. It just happens to be the one that users connect to and has the real data. But from a configuration standpoint, from a deployment standpoint, it should be exactly the same as all your other environments. Production-like environments can be built from scratch in minutes. This is a huge advantage. You can just spin up an entire environment. If you wanted to create a customer-facing demo environment, or you wanted to create another practice environment, doing it through code allows you to just stand up your environments very, very easily. And because it's code, it allows us to do continuous testing of our actual infrastructure. So let's go over some of the tools. Issue tracking. Got tools like Jira, Pivotal Tracker, Bugzilla. It's very instrumental in tracking your actual feature sets and tracking bugs and enhancements to your software. Source control, there's a lot of different ones: Mercurial, Git, Subversion, CVS, Team Foundation, Server. Virtualization software, virtualization tools really help you to do what we just talked about, which is you can spin up environments. So Amazon EC2 and other cloud providers are public cloud providers that allow you to create virtual infrastructure, but there are other tools that you can use locally, such as VirtualBox, OpenStack, and VMware. It can be more on-premise installations. Continuous integration servers, there are a lot of them: Bamboo, Hudson, Jenkins, and TeamCity. Automated testing frameworks. So I mentioned JUnit. XUnit is the .NET equivalent. Or there's an NUnit as well. There's RSpec for Ruby, Cucumber, Selenium, PhantomJS for JavaScript. There's frameworks. If you can think of the language, there's frameworks now for testing. So there's a lot of support for unit testing. Infrastructure as code. There's a lot of great tools. Puppet, Chef, Capistrano are just some of the few. We use Puppet a lot, and it's been amazing what we've been able to accomplish with it. So I'd like to describe a little bit about what we did now. and how we kind of approach this, and some of the lessons learned and the takeaways from our experience, my experience, implementing continuous delivery at IPC. So IPC started with an agile mindset maybe about 3 years ago, and we were waterfall like everyone else. We didn't know we were waterfall because the term agile didn't exist, so we didn't know waterfall existed, but that's what we were. And we decided to start to roll out agile practices and try to do it everywhere. And we didn't just cherry pick projects and say, well, we're just going to try with a very small project and see how that goes. We actually picked the biggest project we could possibly think of. We wanted to take it to the payment processing platform. So this was the project I was primarily involved with up until just recently. And it's the payment processing platform for all of the Subway restaurants in North America. So this processes all the credit card transactions for 28,000 restaurants in the United States and Canada. Subway is only one of 2 retailers in the world that actually process their own credit cards. Everybody else goes through a third party. Walmart's the other one. So we actually have our own credit card processing system. The vision for this was really not to just be able to process payments, because that's pretty much a commodity thing, right? We can go to First Data, or we can go to Payment Tech, or anyone else and just process payments. The vision was, if we own our own payment processing platform, the sky's the limit. We have the payment is just a vehicle. All the wealth of information you get from all the interactions and the ticket items and what they're buying and when they're buying it, all that sort of data was really the vision for owning and going into such a crazy venture, was to be able to actually own that. But in order to realize benefit from that, you have to be able to move.
That's Citrus
Sure.
on the line?
What is it?
What are they saying?
Okay, so I think everyone wants to pause for Q&A.
Okay.
Okay. So
How much are you?
I have about one or two slides more if you want, and we can pause in about a couple minutes. I'll just go over this real quick. So just to continue with this, this system processes 2 million transactions every day, which is about $6 billion in credit card sales annually. And it also, in addition to credit card payments, it also manages the 200 million Subway card, the gift and loyalty cards out in the field. So every time you swipe a card, it's actually running through the system. And we have a 5 nines service level agreement, which means we can be down 5 minutes every year, which isn't a whole lot of time. There's no maintenance. There's no such thing as being able to bring the system down to upgrade. So the biggest challenge of this was that in order to realize value in the system, we needed to be able to introduce features to it all the time. And we want to be able to do it on a weekly basis, not monthly, not quarterly, not annually. We need to be able to introduce features as quickly as the business needs them, as quickly as it's as possible to develop and deploy and see them in production. So this was the big challenge for us. And the solution for us was to transition first from waterfall to Scrum, very important. We immediately went into weekly sprints, with the big takeaway there being that a sprint ended and resulted in a deployment into production. So weekly sprints resulting in actual weekly releases into production. We embraced the DevOps mentality and the continuous delivery, which is that everybody owns the process. Developers are very, very important to the process of actually deploying the software into production. And we invested in a very, very comprehensive testing approach. We spent months building a lot of infrastructure to allow us to go very, very fast, because we can introduce changes into the system and test it and just go fast. So just to give you an idea of how much we test, we have over 3,600 unit tests that run every single time a developer checks in code. We have over 4,500 functional tests, which test more complicated interactions between the moving parts. We have over 7,000 regression tests that test everything from happy path and a card is closed and credit card payments declined, but you ordered this and that, etc. And my favorite is we do a lot of disaster recovery tests. So because the system is distributed and actually there is no single point of failure, there are a lot of things that can happen. Networks can go down, data centers can go down. So we actually have tests that run nightly that simulate chaos. They simulate servers shutting down and data centers going down and things just going bad. And it tests the ability of the system to recover and actually make sure that everybody's balances and all the money and everything is exactly what it needs to be. So I just thought I'd finish with a very interesting phrase here, which is, why do we always have time? Why do we never have time to do it right, but somehow we always have the time to do it over? So real quick, I promise this is the last slide. So the keys to success for us, I'd like to share with you some of the things I feel were instrumental in our success. Was we actually had an organizational commitment to Agile. It wasn't just a small team saying, hey, we want to be Agile, it's kind of cool and we want to do it. Or it wasn't just the executive team saying, go be Agile and figure it out and just go ahead and give us quick business value, but not actually allowing you to do everything necessary to do it. It was an organizational commitment from top to bottom. We created small focused delivery teams rather than having departments where with segregated silos of responsibility. We actually created smaller units of product teams where everybody was accountable for the product, from the development of it to the prioritization of the backlog, all the way through to the delivery and the deployment into production. We embraced that change is always going to happen, so we really invested in our assembly line. We really spent a lot of time making sure our assembly floor, as we call it, is capable of allowing us to change one line of code, even if it's just one line of code. It's very easy and very cheap to just do that, not a big deal. We treat agility as a corporate asset, so it's not just to say, it's not just a buzzword, it's not just something that says, hey, we're agile, so look at us. It's really the way, it's a cornerstone of everything we do. We're agile in everything, not just in the software development, but we're agile in the way we organize ourselves. We'll change desks on a whim if we need to. We'll change whatever. So it's a truly agile mindset. And one of the most important things is when trying to grow our team, since we have these specialized product teams, we always favor a cultural fit over technical skills. Skills can be taught. You can bring people up to speed. You can teach them how something works. But getting somebody that's excited about working in that environment, working in such a fast-paced team, and embracing the DevOps and mentality of done was more important for us than anything else. So I apologize for going a little bit over. So there's still a little bit more to do. Release managers are a thing of the past. We've moved into the phase where now, at a minimum, most companies are at a point where they can do continuous integration. They can at least build their artifacts automatically. They can at least get code into their repositories and build automatically. The next evolution of that is continuous delivery. Once you've got there, you can build on top of that and get to the point where you can actually make your pipeline smooth and deliver repeatable and reliable products. Then there are companies that are doing even more than what we're doing here, which is continuous deployment. Netflix is one example. Netflix deploys several hundred times a day into production. So if you can imagine, if you can think a weekly release is it's a pretty good milestone. But I mean, when you get to the point where you could just release 100 times a day, you're doing something right. So the future's here. It's just not evenly distributed yet. Okay. That's it.
So how is the question and answer session going to work for us? So since we have several facilities, you guys actually have first crack at Ariel. So basically we just need questions from the audience. They're probably not hearing me, so I'm trying to raise my voice. I don't know if that would travel that far to the group, but that's our first session here. So do we have any questions that we want to share? I'll get closer. Yeah, just start chatting.
Oh, wow.
Any questions? So Ariel, just do me a favor. Guys, when they ask the question, Ariel will repeat it. That way the rest of the group can actually
Okay,
hear
so
that.
for everybody on the call, what we're going to do is we're going to take calls. We're going to take questions from the folks here at Carnival first, and then we'll rotate around to the different sites just to make sure everyone gets some questions. So
How does it fit in with APM, application performance monitoring and measuring, because of the distributed nature, the quick turnaround time, and the different platforms? You have disaster recovery, built-in testing. How do you look at that?
okay, so the question is how does automatic or
Application
performance
So it's
monitoring
monitoring and measurement.
and measurement fit into the whole system? Well, it's automatable, first of all, which means it fits in very nicely. There are a lot of tools that allow you to plug in your build process into these tools. You can automate all these things. So one of the things we do is, as part of the functional test that run, every time a feature is released or built, it goes through different layers of testing. So it'll first go into a unit level testing, which happens at the point of integration on your continuous integration environment. Then it'll progress into your your sandbox where you're testing your different products for, you're still testing features at this point though. Then you can test a different set of tests for vulnerabilities, performance and stress. So if you have tools that help you measure those in baseline, it feeds in perfectly into that. Because what you want is to develop a baseline that says, okay, this is the way I expect my application to behave under normal circumstances, and you have a baseline. You can now build in things that will trigger a failure if any of the performance metrics aren't within the established ranges that you can expect. So you can stop the line there, right? You're essentially saying I'm gonna put in another step in my line that says, okay, once all the tests pass from a functional perspective and all my security tests pass, I need to make sure my application is still performing right. So I can say, okay, you know what? It's not performing because this particular function is slow. I'm going to stop the line. You know, but you can play with those ranges and determine what's a failure or what's not.
Gotcha. Very good, thank you.
Ariel, how long did it take you guys to go from waterfall to where you are today?
Okay, so the question is, how long did it take us to go from waterfall to where we are today? So agile is a continuously improving thing, right? So it's not, there's no end point, right? But I would say that the commitment to go to agile was immediate, and I would say it probably took our team and the payment team a good 6 months to a year to get to the point where we felt like we actually had a grasp of what we were doing or what we wanted to do. And that you know, those 6 months to a year were a lot of iterations, not just product iteration, but actual process iteration, you know. And the commitment we made was, hey, let's try this, and let's commit to give it a week or two and try it. If it doesn't work, we'll scrap it and do it again. But let's just all buy in and say, we're going to try it and see what happens. And, you know, we bumped our heads along the way, and a lot of things are no longer look anything like we started. But if I had to say when we actually turned the corner, I would say probably about six months. 6 months we started to actually get our footing, and get our feet under us.
And how large is your team over
Okay,
there?
do apologize. We have a lot of people wanting.
So real quick, how large our team was around 9.
Now, just keep in mind, I know we have a lot of questions. We're actually going to take all the questions down, and we're going to actually post it on our site, and we're going to have a lot of people contribute to responding to those questions. Okay, just keep that in mind. So we will be gathering your questions. But let's try this side of the room. Saw a couple there.
Let's see, I guess I have a few, but just in the spirit of kind of keeping them short. How many development streams do you have going into that continuous delivery pipeline? Do you have a single team that's in that pipeline, or do you have multiple delivery development streams in the
So on the payment team, we had, at the height of it, we had 7 developers all working on the mainstream. So
Okay.
we're working just basically on the default branch, if you will. I think that's the sweet spot, having 5 to 9 people.
But do you have multiple development streams working on a single continuous delivery pipeline?
Yes. So there's people were pairing. So we have people pairing on one feature set, another feature set, but
No, I mean
Products.
from
How many products?
From Scrum
Feeding
teams,
into-
think about it in terms of more of a heterogeneous
Scrum.
environment. No, think more of a heterogeneous environment, not a single application, but perhaps what becomes your end product being composed of more than one
Sure.
component, right? And therefore, if you have multiple streams of development, Scrum teams, whatever.
Clum
you
Scrum
call them,
teams, yeah.
essentially, do they ultimately merge into a single continuous delivery pipeline, or did you have individual continuous CD pipelines for each of the different development
So we
streams?
had both. We had both. So the teams, if they were working on a completely separate part of the application or a different application that's part of the ecosystem, they could still do their continuous integration in a separate stream, but then ultimately it does merge back into a primary stream,
Okay.
where everything at the end does. So this payment system is actually several products being worked on by multiple teams.
So then you're still having to deal with things like multiple branches and merge operations that lead to a single
Yes.
to a single delivery, right?
Yes.
Okay.
Yeah.
So how does that sort of play with the concept of building once and deploying once when you're having to deal with that merge component that later ultimately creates a different binary?
Right.
You know what I mean?
So the teams could work on different branches, and they'll have different environments that test the binaries in a branch mode. But the binaries that actually progress through the pipeline only come from default.
Okay.
So what happens is, ultimately, whatever you're building doesn't matter until you merge back in. When you merge back in, inside the continuous integration server is where all the branches are compiled, merged, and then the binary is built from there. So if there's a problem there, it's detected at that point. Right?
And so.
Okay, hold on a second, because we're asking a lot of questions, which is fine, but I have a problem, because I have people remote wanting to hear that. So what I need you to do, Ariel, if you can do me a favor, make sure you get close, even though the camera might not see you. It's tough, because some of the questions were very long-winded, and just repeating it, either we have a couple of options, either you get up and get right next to Ariel,
Makes
or
sense.
Ariel, move around and you know.
So the last question was how do you handle separate streams of development with teams potentially working on different features, either of the same application or other applications in the ecosystem, and how do you handle merging and making sure that there's a single pipeline of artifacts being built when you have potentially separate branches of development happening? So the answer is you still have to your pipeline still is funded from your default branch. So all your development is happening in branches, but when you actually start to build your binaries and push them through, you're still going through defaults. So everything has to merge back in before it can get into you.
Do you have multiple toll gates? This will be my last one. Do you have multiple toll gates, those happening in the development stream and then happening in the continuous integration stream? So you have unit tests and code reviews happening in the individual code stream and then happening again in the single in the
Yes. So the question is do we have separate different gates across these potentially multiple streams of development? The answer is yes. So if a team is working on a branch, there's unit testing happening. They're pulling constantly from master in to make sure they've got the latest of the default, and they're running their unit tests for their new features separately. They're running a certain amount of functional testing, but they ultimately have to push that back in, and then the same test run again to make sure all the branches as they merge together work. So there is a complexity to that part, but yeah, you have to do it that way.
Okay. I'm gonna remember you. But again, we still have additional questions. I'm getting good vibes from the people online, so they're okay with us continuing the questions here. So if you have additional questions, again, please do me the favor, either go up and ask the question, or Ariel, let him get closer to you. So I'm gonna avoid this side for a little while. He killed you guys over here on this side. I do apologize. No? I'm gonna go back to the right-hand side over here, or left. Any questions here that you guys have?
I have a question.
They might not have questions. So. Okay, we're moving back. Not
You guys have-
So,
again, do me a favor, just quickly stand up a second. Meet Ariel. You can shake his hand. He's allowed to shake his hand and everything. Yeah.
so Ariel, what kind of metrics do you collect and track, and how do you use them to monitor the health of your continuous delivery pipeline? I don't know, acceptance test coverage, cycle time, dimension. What do you use and when do you use them? Because that info helps us.
Okay, so every type of test, every category of testing has a different threshold for what's passing and what's failing. So functional tests are very easy because it either works or it doesn't. It's very black and white. If a feature is supposed to work a certain way, it either works or it doesn't. When you get into performance metrics, when you get into levels that are a little bit more, that have some ranges, then we create baselines that say this is the accepted threshold, right? Because there's variations. If a particular operation is supposed to take between half a second and a second, we know those boundaries and we can set those thresholds. So we can say if this particular test takes a second and a half, we consider that to be a failure. So it depends on the type of tests that we're running. So the metrics that we collect during the continuous delivery, during the actual deployment phase, it varies by test type. That make sense?
But do you have some metrics that your management team monitors in terms of knowing, how well you're doing in your continuous delivery, and in terms of unit test coverage? Are the developers being disciplined in doing the test-driven development, and do you have sufficient unit test coverage or acceptance test coverage? Cycle time, just mention something. So you guys do any of that, or maybe you don't?
So the question is, do the developers have discipline to to write the unit tests and to do test-driven development, and do we have sufficient coverage?
Do you have metrics to
Metrics.
to,
To
gauge if they're doing it
verify
properly.
the effectiveness or tracking? Are you basically continuing or championing or the stuff that you're sort of saying? Essentially, do you track code coverage? Is that a measure?
We track
for
code
you?
coverage.
Do you have a formal process? All right, you do.
We track code coverage, we
Okay.
track the number of unit tests, we track the number of functional regression tests that I mentioned here, so we do track that. Whether or not what you do with those numbers, you gotta be careful with, because if you try to gauge how valuable this is strictly by how many unit tests you have,
Or code coverage.
or just by code coverage, and there's different ways to do code coverage. So we do, for informational purposes, the way we track whether or not something's working is really how quickly we can get stories and business value out. And it's really how we try to measure, which is difficult to quantify. But ultimately, it's really about the business being happier. And the biggest metric is you ask the business about how well we were when we were waterfall and how long it took something to get out there and how much time we spent fixing bugs. Whereas now, I think I would confidently say the amount of time we spend fixing bugs is less than 1%. We don't fix bugs.
Less than one, I'm sorry, didn't hear that.
Post-deployment bugs,
Yeah.
Post-deployment bugs. Yeah, I mean, we find bugs that have maybe been there for a long time, and once we find it, we put it back in and fix it, but features we roll out are pretty much bug-free.
So the question relates to what Ariel was talking about, multiple scrum teams working on one main branch, right? Does the mainstream get the weekly bills out, or is it the branch, the other peripheral teams working on that branch be part of that weekly bills that you take to production?
Yes, so the question is, if there are separate teams working on different branches, does the work that the separate teams do make it into the weekly release? The answer is yes. So we expect let's say there's a feature on a branch that takes 5 sprints to work. Right? So obviously it's not going to be ready in 1 sprint because we release weekly. We expect features and code to be written in a way that it can be incorporated into the main and shippable. So when I deploy it, it doesn't affect anything. Maybe it's not working yet. Maybe it's not visible. It's toggled off, or it's just not even connected or hooked into the actual application. But by doing that, we're actually mitigating our risk because code that's being built is actually going into production, right? And it might take 5 weeks until the actual work is complete and ready to be toggled on and used. But by that point, we've deployed 5 times. We've got much less risk. We're much less concerned about the feature, right? As opposed to waiting 6, 7, 8, 9, 10 sprints for a feature to be completely done, and then merging that back in one big thing, and then hoping that all those changes you did for 5 weeks are good. So the idea is we want to push everything in a way that's every week we're cutting a release, even if it's empty. Even if we have no features, we're cutting a new release because our ability to do that. The ability to do that is almost more important than what we're delivering.
It's a more granular question, but in test-driven development, writing a unit test and you're doing red, green, refactor, is there a key to kind of knowing when refactoring stops? Because you know what I mean? Because there's a point at which you kind of done enough. How do you know when you've done enough refactoring?
So I like to think of it as if you check out a piece of code, if you check it in a little bit better than when you checked it out, then that's already good, right?
Okay.
Software usually degrades over time. That's what we're used to, right? It's like, oh, this code base is 5 years old. If I told you a code base is 5 years old, you automatically think, oh, it's probably bad. But if we actually said every time I open up a file and I find a little opportunity to refactor just a little bit, I'm assuming there's a test case for it, hopefully, or else I'm going to have to find somebody who wrote that and talk to them about that. But if there's a test case there and I'm free to refactor, if I find something and I make it a little bit better and I check it in, my application's actually getting better over time. So
but it's
yeah, you
smart-
could easily
smart
overdo it.
doing
Yeah, you can easily just refactor and just spend all your day refactoring. But there really isn't, I mean, you should refactor it to the point that you're happy with it and the functionality works. That's really the point of test-driven development. You make your test fail, you write your feature with the simplest implementation you can to make it pass. Right. And then over time you might find a better way to do something and you just refactor a little bit better.
So you might find that the quote-unquote quality of the code might be different under that approach than
Definitely.
you know, maybe less quality, but functionality works.
Functionally, it's the same, right? You know, if it performs the same way from a
Right.
performance standpoint, if functionally it's performs the same way, then, you know.
Okay. Go ahead, keep going.
Okay. Can you talk to us about cost? How expensive is this? I mean, you mentioned a number of tools for infrastructure as code, for the integration environment. You know, can you talk to us about your experience in the tools that you have, and you know how much this cost? And in cost from a holistic perspective, in terms of even for your continuous integration environment, if you have to create a build grid with multiple servers to keep your commit stage short enough so that people are not waiting extremely long for the build and the at least that commit stage to finish. Like, did you find yourself making big investments
Yeah.
or in infrastructure
In support of
and
your
support of
10,000 tests.
Yes, exactly.
So the question is what are the costs like to build something like this in terms of tooling, environments, anything infrastructure to support something like having all these different environments, for example. So the tools are not expensive because there are a variety of tools that are free that you can completely use. So source control you can get free. Git and Mercurial are free, for example. Build servers, integration servers, you can get free versions. In our experience, and most companies prefer to buy commercial products or something that has a commercial support license for it. So to give you an example, we use Bamboo. We use a lot of the Atlassian products. So we use Jira, which is a paid product, but there's also a free version of it. But there's a lot of issue tracking software that's free. There's a lot of integration, continuous integration tools that are free. There's a lot of NUnit, JUnit, those are free tools that are all part of this. When you get into virtualization of actually having, being able to spin up environments, then you get into either you go into a cloud solution like Amazon, and then you pay per hour of usage, so you can spin up an environment, run your tests, and spin it down, and then you can save money. Or you can, if you invest in your infrastructure and have a virtualized infrastructure on premise, then you can spin up your servers on your own, and you basically have your private cloud. We use VMware, which is it's an expensive product, but it doesn't have to be that expensive. So I can't tell you exact numbers, because I really wasn't a part of the pricing of that out. But you can get a really good sense of what it would cost on, let's say, Amazon to spin up, depending on what your application is. If you needed 45 servers to run up an integration environment, let's say, because you have all these different parts, you can definitely price that out. But I can tell you that it's not expensive. It's probably more expensive resource and person time and investment time on actually dedicating resources to automate these things, building tools that allow you to spin up or provision servers as needed, and tear them down, execute your tests, run them, deploy, build your artifacts, all those kind of things. The investment on the people and on your resources is probably more costly than the tools. The tool sets are.
So did new roles emerge in your organization as a
Yes.
result of this? So what are some?
We saved $7.8 million. Stephanie's telling me we saved $7.8 million.
You saved?
The roles. So the question was, did we get a lot of role changes in the organization? Yes, we had QA people that were QA department before when we were Waterfall. We had those people we dissolved the department, the QA department, but they now became part of the team instead. So when we said a delivery team, we said we had 4 or 5 developers, and we had QA people with QA backgrounds, formerly in the QA department, actually part of the team. So rather than just making them bug finders, we actually leveraged their QA skills in helping us determine the test cases we wanted to cover, the things we wanted to know proactively, so that by the time we're into the development part of it, everybody agrees on how we're going to test this. And in a lot of cases, we had people writing test cases. So we built a framework that allowed us to write in very, very simple terms. As long as you were slightly technical, you can create very complicated test scenarios so we can have our QA people writing our tests before we're even actually implementing any features, and building that up and running our tests and failing, obviously, because our version of software doesn't support those features yet. And then have our developers write unit tests, build the software up, deploy it into this environment, run our tests, and pass. So, we had that shift in role. We had project managers that were formerly project managers, either became product owners. In some instances, they became they became part of the team in terms of their role, and scrum masters. Certain project managers went more into a scrum master role, more of a facilitator role.
So I kind of feel more like agile, but more for continuous delivery. Would the new roles emerge as a result of continuous delivery?
Nope.
No. So automation guys, who the only role is automation.
Everybody's role.
Infrastructure as a code, DevOps guys that weren't there before.
Yeah, so the question is, were there any actual technical roles that changed in going to a continuous delivery model? There were some guys that actually had more affinity for Puppet and the infrastructure, but that's just an area of focus. But it wasn't really a role. It was just, hey, this is the guy he went to the Puppet conference, he went to the training, and he's an expert. We know a little bit about it, but we're all basically responsible. There's no release engineer. There's no Puppet master. There's no everybody was responsible for everything.
So one of my main responsibilities as a Scrum Master is to make sure that we're on time, make sure that it's time boxed. And I don't think I've done that great of a job today. But we do have more. Okay, so this is the continuous delivery that Ariel did a great job. Thank you, Ariel. Great job. For all the different satellite locations, we have them. Now they're doing their own exercise right now, which is great. So each one is pairing up with a specialist on their side. Okay. So on here, we also have several people, Ariel included, that are here to help you with Agile. Okay. So we've got Stephanie here that works also for IPC. She's an amazing person, Agile evangelist. I look up to her. And then of course we've got our own, representatives here that can help you. But before I get started, I need to make sure a couple of things were covered that I missed, because I was so excited to get Ariel out here to you guys that I missed a couple of things. First of all, there's a lot of great people that participated. So we actually had IBM, Suzanne Erwick, actually help us with the food here. So I gotta thank her. You'll see all the Carnival representatives. We've got Tony, of course, is here. And then we've got Ariel, Stephanie, and Jorge here also, which is a great help. Again, Jorge also contributed to the High Performing Team Conference, which is an amazing event that worked out for us. And then we've got a lot of other, the Care Cloud representative, which is Dave Russell, and Ernesto, that was also online. Okay, so again, thank you for all the teams. We're doing this on a regular basis. The next event that's coming up, called the IT Palooza. I know maybe you guys have actually, I know there are some people actually participating. Where are you? There you go. All right, so we got one of the members that's actually going to present over there, and myself too. That one you don't want to miss. So again, we've got other events coming up. We want to make sure that you're attending that. So now to conclude this, we really want to start, having some more conversations. Again, we have a bigger picture from Agile. So there's a lot of questions that you can ask us related to the whole, implementation. I know you started already hitting Ariel with some of those global implementations, but we have a lot more to share. So we're really taking approximately 20 minutes, so it's not going to be a long-winded, but you have the floor. And Stephanie, you can proceed to ask questions. So Stephanie Sylvester.
Thanks, Rick. So I actually had the pleasure of working with Ariel on the credit card processing platform when we were, and I started out as the QA manager, and then when we dissolved the QA department, I became part of a QA. I became a developer with QA background.
Yeah, if it's echoing, don't worry about it. Let's take it off. I don't know how Ariel did it. I was completely. Oh, you weren't? Because I was actually Look, it's echoing. I was trying to talk, and it kept echoing.
Let me try. Let me
Yeah,
try.
I know, it's a
Okay.
difficult task.
So, and then I became the Scrum Master for the project, and it's basically like what Ariel said. It took us about 3 years to get to where we are, and we started with a very small project. I was part of the team that said, let's bring Agile to IPC, and how do we make that happen? We started with a small project, and we got such success that one morning we got in, and we were like, oh, everybody's Agile, and then we took this big, hairy, audacious project and brought it in-house, and Ariel, and the one thing that Ariel doesn't talk about is that we were able to build this platform and maintain it with about 17 people. So I did a survey while we were in the middle of this just to see whether or not Agile made sense, and we talked about how much does it cost, and I answered the question from a different perspective of what the cost saving is, because everybody talks about how much does it cost, but nobody even stops to think how much money did we save. So I asked somebody that had a long history in banking. I said, this is what we're doing. What do you think our team size is? And she said, well, the minimum amount of people that you could possibly have working on this project has to be about 75 people. And I said 17, and she's like, there's no way you guys can be doing this with 17 people. And we said yes. So the thing is that some of the benefits of Agile, it's not about, it's really hard to put the number on, but when you think about it the next way, like you can quantify a missed sale, you can quantify a missed business opportunity, you can quantify that. And if Agile shortens your development life cycle so you don't miss those, or you reduce the number of misses, then that's what we advocate. And when we talk about how do you track the metrics, so like all the code coverage is important, but basically, did we put the feature in production when we said we were going to put it in production, and did it meet the business needs? Are we driving business value from it? That's our litmus test. And that's a very binary question, yes or no. There's not a lot of, and then you can put a number behind that business outcome. So I just wanted to do that, but we're open to questions from an Agile perspective, continuous delivery, continuous integration. I know some people are always curious, how does QA feel? Somebody with a QA background, how do they feel about Agile? I thought I had gone to heaven. It's really, really good to be able to be on a project and put stuff into production and not have to worry about defects. We had at one point a production support swim lane that we eventually got rid of, but because as we got better and better, we didn't have any production support issues, or they were so small that you could work it into the project as we were going along. So, any questions?
Yeah. Ariel had mentioned that there weren't really any new specialists involved in the automation and stuff like that. So I'm assuming that you had a bunch of PBIs where developers would develop the automation tools. Like, what percentage of did you initially just have a bunch of PBIs for automation, or did you kind of go in sync with some features as well as automation side by side? How did you go?
That's a good question. So I don't know if everybody heard that. The question was at the beginning when we were trying to build this automated environment or pipeline. Did we write up a lot of stories or product backlog items to address that, and at what ratio of that versus actual features did we start out with? At first, we started out very, very heavy on building up this infrastructure because there was none. There was absolutely no infrastructure. We had 0 unit tests. We had 0 functional tests. I mean, we had a couple of minor things, and we had, we could tar up our application, and then that's about it. That's about all we could do automatically when we started. So hand it over and let somebody untar it and unpack it and put it in the right place and on all the 50 servers and all that. So that's where we started. But we spent a good 2 to 3 months worth of sprints alone, just building up our framework that would allow us to write tests. So it was just our test runner, basically, if you will. So we wrote our test running framework, and we started out with a handful of tests. And then over time, once that started to get better, the ratio started to come down a little bit more. And then we started to be able to go a little bit faster because now we could actually use some of that infrastructure to get features out into production. So it started out very top heavy, and then over time it got less and less, and it's never been zero. We're always making still tweaks to the process, and we're always adding tests. But yeah, it started out, I would say, for a good 3 to 6 months, we were really investing heavily on getting everything automated. If I had to do anything manual, I wasn't going to do it. I just had to automate it. And so yeah, it was significant up front, but it really depends on the nature of what you're automating to,
Yeah.
and how far you are, right?
Yeah.
So if you're starting out real behind, then you've got a lot of catching up to do.
It kind of goes back to that slide that Ariel had, that where we think that we don't have time to do the stuff right the first time, but somehow we think we have time to go back to it. And on other subsequent projects that we've been on, I've been very adamant about making sure that we have time to test. So I'm actually having an ongoing email war with some people right now to say, I am not going to write up your roadmap, and I'm not going to complete your roadmap, and I'm not going to write your user stories until you say you're going to put some time to implement automated regression testing, because every time you do a new feature into the application becomes unstable for about 4 or 5 days. And I'm like, this is crazy. And then we stabilize it, and we go, and we put in another feature, it becomes unstable again. So it's again, it goes back to that thing where, and we have a little bit of a luxury, I think, but I think if you make the case that people look at the tangible cost, like, I go and I buy a pair of shoes and I pay $50 for it. That's the cost of my shoes, and that's how we process things. But that's really not the cost of the shoes, because if you have to buy 3 pairs of shoes in a year, the cost of your shoes is $150. Or you can go find a shoes for $75 that you only have to replace every year and a half, and your cost of your shoes is less. So that's a thing. Question?
How did you help the culture change? How did you help the culture change to get a product owner to be disciplined about helping groom and work the backlog to do weekly releases? Especially you come from waterfall and people are used to laying out and these long requirements and all that. You have to be extremely disciplined to be able to get enough in that product pipeline to do weekly deployments, and you have to get them engaged and then show them during the unit test in that environment, the integration. I'm just wondering how you get that to happen.
Do you want to take that, or you want me to take that?
Sure. It's not easy, right? It takes a long time to get off of that mindset where you're not laying out the roadmap, because even though you deliver weekly and you have sprints, the business still wants to know what you're doing 9 months from now, and it's very hard to do. But what the product owners have been successful at doing is, with the team, is being able to predict 2 to 3 sprints out, right? And keeping that focus on just enough, just in time. You find that if you can at least be very, very firm or very close to being able to deliver what you say at that level of granularity, the business tends to be a little bit more relaxed about longer term stuff, because the understanding is the farther out you get, the fuzzier things get, right?
That's right.
But if you get really good at saying, look, I can't tell you how long this is going to take, because this is a very big thing, and it feels like 4 or 5, it feels like 8, 9, 10 sprints. Feels like that. So I can give you that at a 50% level confidence, but I can give you what we're going to do this week, and the next week with 99% confidence, right? So why don't we trust in the process, and then if that feature is still important 6 weeks from now, we'll revisit it in 4 weeks, right? Plan for it, and then in the next sprint it's in and it's in production, and then we just keep going. So it's not an easy thing, but you almost have to build up the credibility. You have to sell the process by delivering value. You have to actually be able to say, look, this feature went from concept to production in less than 2 weeks, and it doesn't matter the size. And we've been able to do that a number of times over the last 2 years. It's staggering the kind of things. I'll go to conferences where there's other financial companies. Financial companies are the worst at this. We tell them that we release a brand new thing, a brand new feature every week, and they don't know what I'm talking about. Right? They think I'm talking about releasing it to like at a development environment or some other testing environment. It's like, no, in production, we release in production. And and we don't have maintenance with them. So we had 100% uptime last year. We were not down at all. 0. So it's kind of important because there's a lot of money going through, and it's it just proves that the process, the approach to software development, the approach to doing this can work in even the most critical of applications. It doesn't just have to be a website, like a simple website or something.
Very good.
I saw a hand up here.
Has it changed what you look for in an employee?
Yes.
Can you describe a little bit about what those dynamics are?
Yes. So the question is, has it changed what we look for in an employee? So, yes, we've turned down very talented people because their mindset is more waterfall. Their approach. First of all, it's very hard to find people that have done test-driven development. So that's a skill set that we could say, okay, fine. You don't have the experience in it, that's fine, we can teach you, but what is your approach to it? So it's more about what is your approach to being fast-paced, to having responsibility. Can we put a pager on you? Are you okay with that? Right? If I put a pager on a developer, that feature is going out with test, and it's going to be tested, right? So are you comfortable with that, or do you like to be off in a corner and then just have requirements given to you? Because that's not the way we work. We actually are involved, developers are involved in the process of vetting out a story with the business. So we'll talk about an item, we'll talk about this, and a lot of times developers will give input that the product owner or the business didn't think about, right? It's a collaborative thing. And then what comes out of that is an understanding and an agreement on stuff. So we look for people that fit that model, are actually encouraged by the fact that they can be in a team that they can give that kind of input, receive feedback, and also the accountability is very important. There isn't a singular responsibility. There's no role. You're on the team. You're responsible, just as responsible as the next person, to getting this into production and making sure it's 100%. And if there's a problem, you're just as committed. So yeah, it did change our focus more. It changed our focus away from skills, technical skills, into more cultural. I can train somebody to learn a particular language, especially if it's a development. You can learn a language in no time. But if you have a strong sense of how something should be done and certain things, then we can definitely work with somebody.
Just to add to that, we actually worked with HR. I worked with HR and helped redefine our whole recruitment process and our strategy for recruiting, working with recruiters, onboarding, and that actually also helped us in terms of getting high quality candidates. So before, when we were waterfall, it took a little bit longer to get the response, and so you might find a great candidate, and by the time you give them an offer, they already have something. And we were very deliberate, just like Agile. We actually took the Agile approach and revamped our recruitment process and got it down to where, from the time we have the first touch point, so not the first, we're not counting the first touch point that a recruiter has with the candidate, but we have the first candidate, first time to have first touch point to when we say a yes or no on a candidate, not including background and credit check that we have to do, is about 5 to 7 business days. And so that has been able to help us get really high quality candidates. So, yes.
So I had a question, Ariel. Covering a little more on the continuous delivery aspect of it. Can you give us a little more insight as to what exactly you do when you deploy? Do you deploy to all 50 servers in one shot? What is your rollback strategy, and how quickly can you do that?
So most of the time we deploy rolling to all the servers. So this application is designed to be, at least if you're talking about the payment system.
Mm-hmm.
The payment system is designed to be, it's very fault tolerant. So you can have an entire data center and a half down, and the system can still take all the load. which is what allows us the flexibility to be never down and still be able to roll upgrades. So most of the time, unless there's a feature or something that we want to just be extra careful about, we do a rolling upgrade. So we'll take one server out of the load balancer mix, and then we'll upgrade it and then bring it back up, and the other one, and then just rotate the upgrades that way. There are times when if there's a particular, if it's something really, if we made a change to the area of the code that settles the actual money to the banks, that's the most critical area, then we may do it to half of the cluster, and then not to the other half. So we do hedge a little bit when it comes to something that's a little bit higher risk, but in general we just roll. So as far as rollback goes, we try not to roll back. We try to roll forward. So if there's something that's not working, the ability, patching is something we try not to do, or hot fixing. Sometimes we have done it in the past, but if the problem is critical such that it can't wait another week for a release, then we'll go back, make the code change, and put it again through the assembly, and then just do a point release or do an emergency release. But we'll roll forward when at all possible. Does that make sense?
I mean, it makes sense. I'm trying to figure out how that maps still are.
Yeah.
Because we
cultural
can't do
change.
that.
Yeah, I mean, I think the cultural change about, it sounds like you guys married agile and continuous delivery at the same time. So obviously there was cultural change all the way around, but specifically with continuous delivery. And I think of things like risk aversion. I think of things like failing fast and having people be comfortable with the concept of failing fast and rolling forward, like you mentioned. And also folks that are involved with the manual processes today, letting go of those manual processes, which often at this point they think is part of their job security, some of these manual processes. So how did you guys make that cultural shift? And did you pair it with agile? Because did everybody just get in a room and say, we're going to go agile and we're going to deploy every week, and everybody needs to get on this train? So
Yeah.
risk aversion is part of the things that we're going to have
That's
to
a very good
reevaluate.
question.
You know what I mean? Like that.
Yeah.
Yeah, so I'll just answer one part of it, at least. You're right. So the executive decision came down, we're going agile. Either you're in or you're out.
Right.
So a lot of people were out. So a lot of people just chose, it's like, this is not for me.
Right.
But the commitment came down to the fact that, our CIO even flattened the organization. So
Right.
they just said, there are no more managers.
Right.
Everybody reports to me.
Right.
So these are the teams, you all report to me, you guys figure out how you want to form and how you want to do this, and so it's like, so on one hand that's great, but now you've gotten a lot of rope to hang yourself with, right? So it created the environment for people to step up and do that. But you still need the people to do that, right?
Sure.
So some of the people that were in the manual world, they actually welcomed the opportunity to be able to help in the automation process, right? So there's a lot of the operations guys typically are I'm the caretaker of the production environment, and I want to do this like this. So it's like, well, why don't we repurpose your skills and help us build tools? You're still going to have to manage the environment, but you just don't have to click and point and enter everything, right? So there's a lot of that could be repurposed. Some people obviously find that it's not for them, and then there is an aspect of job security. But I think that to really be truly agile, there's no place for that.
Right. And I like the flattening part. I think that kind of
It
makes
really
sense.
made a difference.
Everybody get on board. There's only one way to do these things.
Exactly, and we did a lot of work on our culture. So the 5 dysfunctions of a team, Patrick Lencioni, the advantage, we actually, and he also ran the table group, his group came in and ran some sessions with us, and we actually lived those values. So the base of it is trust. So we're constantly working on trust, creating an environment where it's trust. So the part of the Scrum Master's job is to ensure that the health and wealth of the team. And when we were on the credit card, trying to get this first wave out, I had a happiness meter metrics. That was what I was running, and people would laugh at it, but it actually worked really well. So I would track frustration level, and what was how high your frustration was. Then I would track source of frustration, because if it could be a positive frustration or a negative frustration. And so like when Ariel was frustrated because he ran into something that he can't figure out, that was a really good thing, because we knew that he would be working and not stopping until he got it figured out. It was frustrated because you know, 3 product owners can't figure out what's the priority for the next sprint. That was bad. And so we spent a lot of time working on that. I mean, really focusing on the culture. We did a lot of things that promoted togetherness. We fail, win or lose as a team. You rarely will hear people at IPC use the word I. It's we. A lot of we's, a lot of and to the point where our performance reviews were at a team level. So you can't say, well, I'm the superstar on the team and this guy was a slacker, because as part of the responsibility and accountability on the team is if somebody's a slacker and they're not pulling their weight, you can't just say, well, that's not my problem, because then they bring down the entire team, so everything gets impacted, and that has gotten really good results. And I think the biggest thing is our CIO he's a deacon as well, and I say that is a great foundation. He has a lot of faith, so he put a lot of trust and faith in us, and he ran interference. I mean, he ran interference more than we even realize how much. I don't even think that as a group we truly appreciate the amount of interference that he ran for us to be agile and support us. And he was big on fail fast. So you got a week to mess up and fail and come back around. And those are really important, because if you know that you can fail fast and you only have a week to mess up, and there's people looking over your shoulder, not to bring you down, but to lift you up. That's another cultural shift that we did. So criticism is not viewed as a negative thing, it's a positive thing, it's a growth opportunity. So our retrospectives are very important. We have retrospectives, and we would have a list of all the stuff that we had to work on, and then we would prioritize and say, okay, these 3 we would work on for this sprint, and then had a backlog of our retrospective when we first started. So a lot of work went into our culture.
So I would, again, the culture aspect of Agile is very, very important. I know you guys can take in all the development work and all the skills and say this, but if you don't have buy-in with the team, if you're not actually working as a team concept, she mentioned very great things. We commit to the sprint as a team. It means we all are going to work together to get this done. It's not just the operations team is going to work. I mean, this is not us throwing things over to operations and say, go ahead and figure it out. It's actually working together to get that done. Another aspect that you mentioned was really important is, okay, job security and all that. We do a lot of pairing. We believe in pairing. We believe in having these cross-functional team members working together to understand each other's skill sets, and at least, not fully, we don't think you're completely, but at least understanding. The first time we actually had that DevOps concept, it was amazing. It was an amazing experience to actually go through that. We felt first, oh my God, this is really awkward. Development, but now it seems like you don't want to live without it. The whole communication and how they're moving things out to production and how they're catching things early is amazing. So again, I think from a cultural standpoint, that is the biggest challenge that you'll have, is how do you get everybody to trust each other? Because we hold each other accountable. There's many times you've got leads that come in there and say, hey, what did you do today? And they're actually going there, but in a way that's productive, saying, look, I'm here to help you. When she talked about, evaluations and what we're doing from a team standpoint, what I did from an evaluation was, I want to know what I need to do to make the team better. So each individual was actually assigned to talk to each member of the team and get feedback. And they were responsible also to help me. So if I had a flaw, which I don't have any flaw, I just want to make sure everybody's aware of that, I actually had the team members to help me with that. So again, that team concept is very, very important.
Jorge, you had a...
Yeah, I did. So going back to the continuous delivery, right? you talked about how when you first started, it was, I guess, somewhat of a shotgun approach where everything was really focused on setting up the infrastructure. So a couple of questions on that. How was your funding managed for that type of involvement of the effort associated with it? And how long did it take you to really get the continuous delivery infrastructure in place so that you can really focus on the features alone and get that stuff out the door? And you talked about, it took you 6 months to a year to just level the Scrum Agile development aspect of it. Kind of want to understand the dimension of the infrastructure for continuous delivery and the budget associated with it, if you had to deal with that, or if it was just a headcount that was already committed to the effort.
So from a tool and infrastructure perspective, the organization already had invested in virtualization software already. So we already had resources available to, and lab environments, right? So while we were still waterfall, we still had virtual environments to do manual testing. So that was already there. So that wasn't an extra expense in terms of tooling. And then the investment was mostly in time because we were already using Jira to do tracking of some sort or some other project tool, right? So as far as that goes, source control and all these developer tools are cheap. The investment was really in the delaying of perceived business value, right? And I say perceived because it was perceived that getting this feature out, even if it was the most painful thing in the world. You remember version 1?
Yeah.
Go live, which was not done this way. The perception is getting this feature out is the most important thing in the world, and I don't care how difficult and how many people's weekends and the whole night and marathon deployments need to be. That's more valuable than investing in making this better. So the investment to actually not do that, to do it the other way, is probably the one that was. So it was headcount. It was more not really headcount because we didn't add people to do this. It was just the people that were doing features, the purity features before, saying we're going to stop doing that. We're going to spend time and build this actual infrastructure.
But
And that lasted how long?
but that represents a cost to the company, right?
Yeah,
It has a value.
Yeah.
I'll give you an example. You have 10 people that are on your team. Let's say everybody makes $100,000, right? I mean, so it's $1 million. Right?
Okay,
That's what you're investing. So my point is, if you were doing that, how did you guys get that commitment? I guess from a CIO, go
Okay.
and do this, and it's okay.
Yeah.
Okay. Yeah.
Delaying
So
your
the cost, so the budgeting standpoint. So the infrastructure team was the one that came up with the solution to go virtualize. They realized that we would not be able to truly be agile if they weren't virtualized. So they started a project to do VMware and bring it in Lab Manager to start that up, and they used older equipment, and they didn't realize that it was going to get. So they started out with older equipment and put the Lab Manager on there, and with the Scrum Masters evangelizing why this made sense, we started creating this demand for Lab Manager. And what happened was their SLAs around Lab Manager had to change, because Lab Manager was a development environment, so if it goes down, big deal. So what they did was they started this project. It took off. They had to reset their budget, put money in the budget to buy additional servers, change the SLA around Lab Manager so that it was near production-like, because now we understood that if Lab Manager went down, the developers were dead in the water. And it sounds like it was a bigger investment, but because we went virtualized, we actually realized the savings about $7.8 million, because we have about, I think it's like 800. We have about 800 servers. About 800 servers at any given point in time. We have about 800 servers standing up. We have about 250 employees, just to give you a ratio of people to servers. And we would not have been able to do that from a physical standpoint. And then we created this environment where somebody like me that has a QA background can spin up a complex environment in about 20 minutes. And be able to do whatever I needed to do, and then destroy it afterwards or keep it. So that's the investment. Our CIO is committed to this. the infrastructure people went out and figured out how to do it from an infrastructure standpoint. Put the numbers to buy more servers, realized that if we went virtual, it's do a cost saving was much better. And that 7.8 million is not only number of servers, but footprint in our data center, cooling, electricity, electricity and footprint in our server. So
Yeah, and just back to the resource and the so that there was a cost, obviously, right, as to how many resources and what everybody's getting paid and how long it took to do that. But at the time, the product we were building was actually to replace an existing vendor, which was costing the company $500,000 a month, $500,000 a month to this vendor. So I'm not going to say it wasn't any cost, but at some point the CIO basically said it's costing us more to be on this vendor than it is to and to trust that the team is telling me we need to spend these 10, 15, 16 sprints or whatever amount of time to build up this infrastructure so that when we go live we can actually support this system with fewer than 50 people. So at some point he made the call and said, yeah, I mean, I'm sure he knew the number. I couldn't tell you the number, but he said, yeah, there is a cost to doing this and it's worth it. I couldn't tell you the number though.
The cost avoidance for bringing the credit card and gift card processing in-house is about 19 million a year. So,
Are your production environments virtual? Are you
Not at the
setting
moment.
everything up?
Not at the moment. The production environments are bare metal right now, but the deployments to them are. So we don't expand or contract the footprint of the environment often at all. So it's just a standard footprint. So it is the amount of servers stays the same in our production environment. We don't actually have to scale up or down because the system is able to support 10 times the load as it's currently constituted. But there is a plan to go virtual.
Is your entire deployment process, is it scripted, like start to finish? Are you pushing a button, roll this into?
It is not 100% crypto. So it started out very manual. Then it got to the point where the artifact could get into the production environment the same way it got into the other environments. But that still meant that the installation still had to happen, and the rolling of the servers is still manual. So the process of taking a server out of the load balancer and upgrading it, that part is the taking out of the load balancer is not automatic. So
at your production level, it's not automatic, but pretty much your test level it is.
the way the software is actually, so in our development environments, we don't have the full cluster, right? We don't do rolling upgrades like we do in the production environment. But the way that the software actually gets installed and upgrades and turns itself off and shuts down the existing application and starts up, and all that works the exact same way in all the environments. So there's still a movement for us to get even further and be able to say, get to that one-click option. That's actually, and then be able to even do that continuously.
You mean
right?
like continuous deployment?
Continuous
Instead of
deployment.
continuous delivery,
What is your
continuous
biggest
deployment.
roadblock to not deploying every
Wait,
day?
wait,
right?
wait. Can we get this gentleman over here? He's been trying to get.
I have to actually say that would be the last question.
Yeah, let's
Okay?
just get this gentleman over
Last
here
question.
in a green shirt.
So my question is along the same lines. So you guys are thinking that you're gonna have to go virtualize in a production environment in order to do continuous deployment?
No. The desire to go virtual is different. It's for a different reason. The obstacle to going faster or daily right now is a change control process. That because there's an advice of change and notifications across the entire ecosystem to allow for time to actually communicate changes, potentially as things might affect partner integrations. That's really why there isn't this hardcore press to go faster. Could we go faster? Potentially. There's a lot of automation we could do more to get even to the continuous deployment where we just check in code, it goes, but the need to go that fast hasn't existed like it does in some organizations where like Netflix or Facebook will do 50 deployments in an hour, and it's because they don't actually have to get a change approval from their constituents or from their users. They just roll it out. Netflix will actually have mechanisms in place that code automatically goes through all the processes, goes through all the gates, and when it succeeds, it goes automatically into production. And then there are automated systems that can detect if there's a problem, and it'll automatically roll back within seconds. So they obviously felt the need to build that sort of architecture and spend time to do that because they needed to go that fast. So it really depends on how fast you actually need to go. The business hasn't actually needed to, we haven't hit that point where a week is not fast enough. But
Right, so you treat the continuous deployment as a feature of the software itself. So
yeah.
It's pretty
Yeah.
It's not fine every week.
Okay.
No,
Thank you
no,
very
no.
much, Ariel, Stephanie. Great job. So again, we do this every month. We'll have another activity hopefully in a few months. Keep in mind, we did this pretty quick, so we're learning from our experience here. This is going to be our first take, and then hopefully we'll be able to expand this to not just the nation, the world, different speakers all over the place. That's what my vision or what our team's vision is. Okay, thank you very much for joining us. And please pass on the survey. Thank you very much. And we also have some food left over. So if you're interested in
My
feeding
dinner.
your kids,
Fine.
go ahead and grab some food on the way out.
Yeah?
Thank you.
Dude, wait a second, didn't you used to work at RHI Consulting?
Remote users, thank you very much.
I recognize your face. I didn't recognize I'm trying to hide from you. Thanks for putting this together.